So let's say you're talking about separating things and you're going to use physical or chemical processes. You need to know the difference. The difference is pretty simple. In a physical process, you get nothing new. You get no new substance. So no new substance is formed. In a chemical process, well, surprise, in a chemical process, a new substance is formed. So let's give an example of each of those. Let's say that you've got some water and you boil it and you wind up with water vapor. And what happens when you boil water and get water vapor? Well, water has a formula of H2O, and just to say that it's a liquid that you started off with, I'm going to put an L in here. And then when you get the water vapor has the formula of H2O, and it's a gas. So if you have the same formula on both sides, what should that tell you? That should tell you that nothing new was formed. Over here on the chemical process side, let's say you've got some gasoline, or specifically, let's say you've got some octane. And octane is C3, oh no, wait, it's C8, oh, very sloppy. It's C8H18. If you take gasoline and you mix it with oxygen and you add a spark, you burn it, it explodes like in your car engine. And what you get is water and you get carbon dioxide. So what has happened here with the formulas? What has happened here with the formulas is they have changed. You've gone from this and this to this and this. So what should that tell you? That should tell you that a new substance has formed. So if a new substance has formed, it is definitely a chemical process. Let's see if I can come up with one more example of each. Let's say we've got a whole bunch of stones, and you're going to run them through a sifter. So you're going to sift them, and then you're going to save the small ones. So you're going to sort them by size. And when you run all these stones through a grating or through I don't know, some kind of wire mesh or something, what you're doing is you're keeping the little ones, or keeping the big ones, I guess, and you're sorting them by size. So do you wind up with anything new? No, you don't get anything new, so that is a physical process. One more example of a chemical process. Let's say you've got an apple, and as the apple sits for a long time, you wind up with a rotten apple. How do you know that that is a chemical process? You know that that's a chemical process because the rotten apple is not made of the same substances that the apple was made out of. So you wind up with a new substance. The apple has become a rotten apple. So it has changed into a new substance. So if you want to boil it all down, so what are you looking for? In a physical process or a physical change, nothing new is formed, and the only thing you're changing is only the physical properties change. And what are physical properties? Well, physical properties are things that you can observe without changing the substance, like what color is something, or how hard is something, or how massive is something. If it keeps the same physical properties, then it's a physical process or a physical change. In a chemical process, you can have this, you can have physical properties change, and the chemical properties change. So what does that mean? That means that if you look at this, like let's go back to the gasoline example. One of the properties of octane is that it's burnable. Well, what about water and carbon dioxide? If they are burnable, well, they've already got oxygen in them, but if they are burnable, they're much less so. So that's a change of a chemical property. Can it be burned or not? So in a physical process, you wind up with only your physical properties changing. And in a chemical process, your physical and chemical properties change.